Hey, this is Mr. K. We're talking about addition and subtraction today. These are two basic skills that you'll use the entire year. You'll use them in every math class that you'll ever take in your entire long lives. I guess it's good to kind of go over that now. When we're talking about addition, we're talking about combining quantities or combining amounts to get a sum. Sum is just the answer to an addition problem, just like difference is the answer to a subtraction problem, and we'll talk about that in just a few minutes. When we're talking about addition, sometimes we see terms like addend, that's A-D-D-E-N-D, that just describes the thing that you're adding to get to that sum, but it's not used very often. When we talk about addition, sometimes we have to do something called carrying over, and you've done this a million, jillion times in your math life so far, but it bears repeating. If you have a value when you add up two numbers that is greater than the place value that you're currently placing it in, you must carry over that number into the next larger place value. In this instance, 68 plus 47, the first place value that you're going to add are going to be the ones place value, and since 7 plus 8 or 8 plus 7 equals 15, that 1 in the tens place value of that particular sum must be carried over to the tens place value to be added up, where 6 plus 4 equals 10. Adding that extra 1 equals 11, and that's what you would place here in your sum, and the sum would be 115. When we're talking about decimal addition, we have to keep in mind that the decimal rules where things need to go in that particular problem. If decimals aren't lined up and they are there to protect place value, we end up with a completely wrong answer, and an answer that is completely far off from what we're trying to find. The best example of this would be to use money. When we are calculating monetary values, we're talking about dollars and cents, and when we talk about cents specifically, we're talking about tens of cents and ones of cents. And those two single place values are important in the lining up of those values to accurately calculate a sum or an amount of money we're trying to either save, earn, or get. When we're talking about decimal addition, these decimals are very, very important, and you can tell by these two separate solvings of the problem that there are right ways and wrong ways to solve decimal problems. If you can see why this is incorrect, you can see that there are two different placements of that decimal value. There's a shift there, and in either direction it's going to result in an incorrect answer. When we see a correct solving of it, marked by the yes, we see that the decimals are lined up nicely, and we see all of our place values are lined up. Now what you see here that you may not see here is the fact that there's a 0 there, and that 0 is okay. It's called an insignificant digit. We can use that to protect place value and to line things up nicely. It's not required, but it's something that helps to organize the problem, and if it benefits you, please feel free to use it. In talking about subtraction, and I hope that you can see that, you're going to take two values, one hopefully larger and one smaller, and find a sum by doing subtraction. By using the example 242 minus 71, we can see that borrowing needs to take place when the number at the top of the problem cannot be subtracted by the number below it. In this instance, 4 cannot be subtracted by 7, or 7 cannot be subtracted from 4, excuse me. So we have to borrow. And by borrowing, we mean we're taking place value from a larger part of the problem and carrying it here. So it's kind of like the opposite of what we did in addition. And by doing that, we are actually taking 100 from this place value and bringing it here. I know that seems kind of hard to understand or hard to fathom, because we commonly as math teachers don't talk about it in that context, but hopefully you can understand that. We're taking 100 from here and bringing it here. So this is actually not 14, it's actually 140. And we're subtracting 140 minus 70. If I take off this 1 here, that's actually a 70. To keep it simple, math teachers commonly say that they're subtracting 14 minus 7, but that's not necessarily the case mathematically speaking. So when this is solved, 2 minus 1 is obviously 1. There is no borrowing to be done there. 14 minus 7, or 140 minus 70, equals 70. Like I said, if I take off that 1 and put a 0 there, that's a 70. And I'm left with just 1 in my hundreds place value, and 1 minus 0 is obviously 1. I can break this number down, 171, into its constituent place values if that makes it a little easier. This is 100 and 70 and 1. For the purpose of borrowing, that might be necessary for you to understand how the borrowing is taking place. When it comes to decimal subtraction, the same rules apply. We must always line up our decimals. If we don't, we're going to come out with a really weird answer. And I'm going to actually give you that assignment. I'm going to actually have you take a look at this example here, $83.23 minus $4.09. There are two solvings here. I'd like you to tell me which one is correct, and I'd like you to tell me why that is correct, the one that you chose. And that will be the assignment I present to you. When you come into class, the next class day after this is given, I'd like you to bring that example with you in your notes. I'd like you to be able to explain why you're correct, and that will be your homework assignment. Have a great day.